le podcast.
Humain demain.
I'm with Didier Carnel, Vice President of the French Transhumanist Association, and we are talking with Ben Goertzel. It's an honor for me to talk with Ben because I've been watching a lot of his podcasts. Yeah, I've always been very interested by his views on a lot of topics that I share interest with. So, but maybe for those who don't know you, can you briefly introduce yourself?
I'm a mathematician by original training, which was a long time ago. I got my PhD in math back in the 1980s. I have been interested in AI and other futurist topics since long before that. I guess I wrote my first AI code in would have been 1979 or 1980 when I was in my early teens. And even before that, I remember watching robots on the original Star Trek TV show, and it would have been 1970 or something, and was just intrigued by the possibilities. So I've been chasing notions of AI, singularity, super longevity, and so forth since I was a young child, 50 plus years ago. You know, I was an academic for the first 10 years of my career. I've been doing entrepreneurial AI, R&D, and product development for the last few decades. And now is obviously a very exciting time to be doing any kind of advanced technology, and especially artificial intelligence, which has become my specialty, right? So I introduced the notion of AGI and the term AGI in 2005, though I was working on related concepts long before that. I think I started playing with machine learning applied to genomic data sets related to longevity in 2001 or so, right? As soon as the Human Genome Project completed. But now, 2024, 5 years away from what my friend Ray Kurzweil has identified as 2029, the point at which computers will equal human intelligence. And we seem to be moving in that direction, right? So we're at a time now when all these visions of machines that think like people and therapies to prolong human life, molecular nanotechnology, all this wild stuff is threatening or promising to become a reality quite soon. So it's a fun time to be a transhumanist.
So why do you think so many people are so afraid of transhumanism, even when it is when we speak about positive aspects? What's happening, and even more surprising for people like us, why are people so negative about radical life extension? So we will speak about this also, radical life extension after.
These are questions of sociology and mass culture, which I'm not necessarily the greatest expert on, but I'm happy to share my opinions for what they're worth. I mean, I think the term transhumanism scares people because it sounds like you're going beyond human, and they are human. So it makes them feel like you're going to replace humans with something else, which is not them, and there's no place left for them, right? So I mean, if there was a better prefix that just meant upgraded humanism or something, then maybe people would like it better. So I sort of think transhumanism is, as an act of wordsmithing or memetics, it is scary, and so it's designed to alienate a lot of people and appeal to a small group of radical zealots, such as myself, right? So I'm in, but that's more about the sort of term and meme of humanism than about the underlying concepts. I think what we've seen in my adult life in the last few decades, we've seen most of the core concepts of transhumanism become mainstreamed, right? And I mean, I know my adult kids who are now in their 30s and late 20s, I mean, they grew up on anime and manga and TV cartoons, which were, there's robots everywhere. There's people mind uploading and living in digital realities. There's cyborgs. I mean, all these things are almost common sense, right? So in a way, transhumanism won. I mean, many transhumanist ideas are common sense among educated young people now, even though almost none of them want to identify as I am transhumanist using that term, right? I mean, that's why we changed the name of the World Transhumanist Association to Humanity Plus, an organization that I've been involved in the leadership of for some time. On the other hand, that name change didn't result in the organization becoming any more popular or powerful or any less, really. I mean, I don't think it made a huge amount of difference. So, but it's interesting. I mean, it happens with many other things also. Like I'd say, feminism became mainstreamed in my lifetime, like compared to attitudes about women and men's roles in the US in the 1970s. Almost everyone now is a radical feminist, right? Like almost every educated person in the US now assumes, like, of course, women should be able to get the same jobs that men do, and they should get equal pay if they do the same work. And of course, it's okay for women to choose not to have children, and in a marriage, men and women should both wash the dishes. We take all that for granted, which in the 70s would have marked you as a radical feminist, right? But now, not that many people want to call themselves feminists, but the ideology has won. Like those attitudes are everywhere. So I mean, it happens like that. Sometimes the body of ideas catches on better than the explicit terminology or ideology. And I think on the one hand, that's not so important. On the other hand, having an explicit term and philosophy encourages people to think explicitly about the matter at hand, right? And I don't think people are reflecting that much on transhumanist themes, technologies, and possibilities, not as much as the hardcore transhumanists were in the 80s and 90s even. People are not thinking too deeply about these things. They're just implicitly accepting, like, well, yeah, of course AI is going to become much smarter than people soon. Haven't you seen ChatGPT, right? Like, of course, aging will be solved eventually. We see all the diseases medicine can cure, right? So it's people are almost unthinkingly accepting so many of the core principles that many of us spent decades like trying to beat people over the head and convince them. Now people unthinkingly accept them just because the time has moved on.
Yeah, it's definitely a branding problem, and it's interesting to see that a lot of people who are driving innovation in the big tech companies are actually accepting, without even saying it explicitly, transhumanist ideas, and so that's interesting to see. One transhumanist theme that's maybe not as much accepted is mind uploading. I was wondering what are your view on the topic. Do you think it's feasible, and is it a likely path for humanity?
My kids grew up on mind uploading from shows like Digimon, right? I mean, in Digimon, people just, you upload yourself and you're a virtual character running around doing virtual world stuff, and you come back and you're a human. So, I mean, there's been endless Japanese cartoons on this theme for many decades, right? So, I mean, I think a lot of young people just assume this sort of thing will be possible eventually, but until the technology is there's not much to do about it, right? I mean, the thing is, most people are able to think about, or interested to think about only what is right in front of their face. So like ChatGPT comes, all of a sudden everyone takes AI a little more seriously. Until that point, they're not going to worry about it, right? And I mean, if you tried to get people to think in detail about the implication of birth control pills before the 60s when they were invented, very small percent of the population would be interested to think about a pill that doesn't exist. But then once it's there, people will take it and they'll think about it and they'll deal with it, right? So I sort of think mind uploading is like that. I mean, for most people, it's an irrelevancy. We can't do it right now, right? I mean, if you give them the chance, I suspect people would take it seriously. And if you could mind upload into some form that looked like it would let you have more fun and more goodies, most people will do it. I mean, just like with the immortality pill, people will say a bunch of bullshit like, oh, death gives life meaning. If God wanted us to live forever, he wouldn't have made us die, blah, blah, blah. But then I think once the reality's there, it's like, take this pill and over the next month, your body will restore itself to its healthy 25-year-old form and stay there as long as you want, right? I mean, once that's there, essentially everyone will take it, and all the blah 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 will be irrelevant. So I feel the same about mind uploading. When people will debate the philosophy of it and is important to be in our original human body and so forth. But once the reality is there, I think there'll be a lot less hand-wringing. And I mean, there are philosophical puzzles of mind uploading, but I mean, in the end, there's philosophical puzzles of our own everyday life that we don't really care about. Like, how do we know that each other are conscious beings and that all of you people are not just, you know, meat puppets put here to annoy and amuse me? I mean, how do I know that this physical world that appears to be here has any reality? And I'm not just a brain in a vat deluded to see this physical world by some evil scientist. I mean, when practical life demands it, we're more than willing to overlook philosophical conundra. And I guess the same will be true of mind uploading. That's like the Star Trek transporter, right? If you had a Star Trek transporter, you could step into it, then pop out halfway around the world, or you spend a long time dealing with airport security and stuff, right? You got the philosophical problem. Am I really killing one version of myself? And then the other one is being printed, which is not me, but just some clone of me that pretends and thinks it's me. Almost no one will worry about that when they can just step in and then step out the other side and life goes on, right? Someone will. Some people are afraid of flying too, right? But I think not many.
Yeah, I think it's definitely also a case for a new kind of philosophy to be invented when a new science is discovered, maybe like quantum physics. If the multiple world hypothesis is true, we need to rethink identity and like all those versions of me that exist in different worlds that we can't interact with, etc. So if we have mind uploading technology, maybe I can create a copy of myself, and that's okay. So,
I mean, someone will invent a proof that mind uploading was foreseen in the Bible, I'm sure. I mean, our belief systems are magnificently fluid, right? I mean, if you look at how people interpret thousands of years old holy books in the context of the modern world, I mean, there's a glorious flexibility of interpretation, right?
Yeah, so let's go back maybe to the topic of artificial intelligence. Since you've been in the field of AI for many decades, are you surprised at where we are now? And do you think the current approach of scaling the frontier model will be enough to achieve AGI or super artificial intelligence?
You know, if you ask me what I thought when I started out in the AI field in the 80s, I thought we'd be further along than we are now, actually. I mean, I think hardware didn't go down the direction of multiple data stream, multiple instruction, parallel processing. Things like Danny Hillis's connection machine from the 80s and 90s didn't get continued, right? So we haven't gone down the optimal computer hardware path for AGI anyway, for machines that can really generalize beyond their experience and programming in a dramatic way, like people are more so. We haven't really gone down the path of life like robotics either. I mean, we developed robots mostly to be our factory tools. So like robots don't have sensitive skin, they don't have a sense of self. We don't have fluid movement in our robots, right? So in a number of ways, we haven't developed the infrastructure around in a way that would have been optimal for developing human-like machines, which is why I think it's taken as long as it has to get where we are now. But now, in spite of building the wrong kinds of computers and the wrong kinds of robots, and in spite of almost all AI funding going into either military applications or narrow commercial applications, rather than R&D, sort of open-ended cognitive systems. In spite of all these impediments, we're still advancing very, very nicely now, right? And we've created AI systems that can do a lot of the things that we traditionally thought only humans would do. I mean, including, things like AlphaGo that can beat complex games, automated math theorem proving software, and then chat systems like LLMs like ChatGPT that can hold reasonable, if not fully human-like conversations, right? So, and automatically generate program code from text specifications and so forth. I think we've made huge progress. I don't think any of the software tools out there now commercially have quite the right approach you need to make a human-like thinking machine, but I think many of them are ingredients that can be assembled with other things to make a human-like thinking machine. So, I mean, I think these tools are all helpful, right? Like I think you can scale up AlphaGo or ChatGPT or something to just scale it bigger, make a few adjustments, and get an AGI, a general intelligence, that can make creative leaps of imagination like people can. But I think, we can use modern processors, modern networks, modern amounts of data, and we can build AGI architectures incorporating large language models along with other components, and we can get to AGI that way relatively soon. So, I mean, Ray Kurzweil foresaw 2029 to have AIs as smart as individual humans, and I think we're well on track to get there by then. We could even beat it by a couple of years. Ray also thought and still thinks it will be another decade and a half from human level AGI toward a full-on singularity where AIs are vastly smarter than human, where they're super intelligences. On that, I think differently than Ray. I think it's at most a few years to get from a human level AGI to a massive super intelligence, because I think the human level AGI will rewrite its own code, it will invent new computer science, it will design new hardware. I think a human level AGI can proceed at a pace different than we've seen during even recent human history, just because it's not constrained by the speed of human thought.
I have a question concerning you work on AI and on longevity. So I know that you have projects concerning AI making it possible to advance for biological longevity or biological immortality. But can you go a bit in details about that? Because it was never totally clear to me. What is the project?
Sure. Yeah. So I'd say my deepest research interest in AI is trying to make real thinking machines that can think like people and then create super intelligences. But I've worked on a variety of applied AI projects over the years, using AI to do everything from control humanoid robots. Like I led the software team behind Sophia, the first robot citizen, and using AI for prediction trading on financial markets and a host of other applications. But one of the application areas dearest to my heart has been applying AI to try to understand the biology of longevity and discover new longevity therapies. I mean, this obviously is important to all of us. Like I enjoy being alive and have not much desire to be dead instead. I mean, I don't utterly rule out the possibility of various forms of afterlife. On the other hand, that's all fudgy enough. Like for now, I would be happy to continue in this biological form of existence. So, I mean, this was my motivation for trying to apply AI to accelerate longevity research in some way. Like it's clear that human body is very complex. Aging is multifactorial, and there's many, many different things that go wrong when you get old. And modern biological tools give us an awful lot of data about different tissues of the body of different organisms at different stages in their lives. So it seemed clear to me for a long time, if you could feed a lot of data about different tissues of the bodies of different organisms, the different phases of their life, if you could feed that into an AI system, I mean, the AI may see interesting patterns there related to the causes of aging and death, and the AI may suggest some cures for some of the issues that go wrong as we get old, right? So that's all very general. Now, the specific work I've mostly done in this area has been applying machine learning and machine reasoning tools to the analysis of genomic data relevant to aging and age-associated diseases. And that's DNA data, where you're looking at what are the mutations or the variations, like the single nucleotide polymorphisms associated with different individual organisms, which may have different lifespans or be known to have different diseases. Gene expression data, and then RNA-seq data, so different sorts of data that give you information about the processes happening in a cell at a certain point in time. And then you have other things like DNA methylation data and metabolomic data and so forth. So I've done a bunch of research looking at these sorts of data drawn from different organisms and populations to try to see what machine learning can discover about causes of aging and possible cures. And one reason to think AI can add value here is it was observed shortly after the Human Genome Project and suspected by most biologists beforehand that most disease phenotypes or most phenotypic characters of the organism in general that we're interested in are not caused by any one gene, nor even by a small number of genes. Most observed characteristics of an organism, be it intelligence or athletic ability or susceptibility to cancer or Parkinsonism, most of these complex characteristics of the organism boil down to interaction of a large number of different genes in a complex pattern. Whereas without AI, it's very hard to study data and find what is the complex combination of genes or gene activities leading to some characteristics, right? So like you have a few diseases like Huntington's disease, there's one genetic variation that leads to it, right? But that's quite uncommon. If you're looking at something like Alzheimer's disease, let's say, or even heart disease, the susceptibility to that sort of disease, it's the combination of at least dozens, more properly hundreds of different genes interacting in a few different pathways and networks, right? And before the advent of AI for genomic analytics, I mean, traditional biostatistical methods just couldn't do that, right? I mean, biostatistics tends to let you look at, okay, what's the causal impact of this one gene on this phenotypic characteristic, or maybe two or three put together. It doesn't give you complex interaction patterns. So that's a particular niche that I've explored most, is using machine learning and reasoning to find which complex interaction patterns of genes and proteins underlie different phenotypic characters associated with aging, right? And
just one small sub question. For this, you use health data available somewhere, or to
we
the
use which
genes
data?
for the genes to have the information that you need to feed your AI. Where do you find it?
I haven't operated my own labs, so either we're using public data or we're partnering with labs. So like we did a bunch of work on chronic fatigue syndrome together with Center for Disease Control in the U.S. And then they had a bunch of data, and we were able to use machine learning there to sort of track down that many cases of CFS are caused by lesions in autonomic nervous system, which is interesting. Many others were caused by Epstein-Barr syndrome, right? So yeah, I've done a number of projects together with different labs that have gathered their own data, and then now, in the last 10 years, there's a huge amount of public data that's just placed online, because in the US, for example, the NIH, National Institute of Health, has made a rule that any NIH-funded research, once they publish their results, they have to put the data online. Now, most biologists are selfish jerks and will put the data online in the most raw and least comprehensible and usable way possible. But the data is still there, and you can do something with it, right? So now, let me give two examples of work along these lines. So one of which had to do with inflammation. So what I did there was take public data about inflammation in different human tissues. So there was one study someone published looking at gene expression in lungs that were inflamed versus not inflamed. Another one people took looking at blood that was inflamed or not inflamed. Another was brains that were inflamed or not inflamed. So these were separate studies with the data posted online by separate people. I then merged those together into a common data set of just inflamed across various tissues versus not inflamed across various tissues. Then you use machine learning to try to figure out what are the common patterns for inflamed versus not inflamed tissue, right? And you can discover a lot. What we did then was we tried to find a combination of herbs, so a novel combination of traditional Chinese herbs, so the active ingredients in those herbs would dock with the proteins coded by the genes that characterized inflamed tissue, right? So then you could give people a supplement, and it would help with inflammation. It would decrease level of C-reactive protein and make them feel better. So this was marketed as Inflamex by the company Max Life, run by my late dear friend Dave Kekich, and we did some clinical trials showing that worked. Now, supplements can be valuable. In a way, it's a blunt instrument. So could you take the same findings we had about the causes of inflammation and try to use those to design like a drug cocktail, a bunch of small molecules? Certainly. Could you use that to drive gene therapy aimed at decreasing inflammation in certain tissues? Yeah. I mean, we didn't do that because it's more expensive, whereas designing a supplement was easy to do on a low budget, right? Another example, which more pertains to my current work, is I've worked off and on over the last decade with Genetian, company founded by Michael Rose, which has created a population of long-lived flies called the Methuselah flies. And these flies have been bred, they've been experimentally evolved over 40 plus years now. They just took flies that reproduce late in life and mated them with other flies that reproduce late in life. And then they got super long-lived flies. But you don't know why they live so long, right? Because they weren't genetically engineered to live a long time. They were evolved to live a long time by experimental evolution. So then you can look at DNA of long-lived flies. You can look at RNA of long-lived flies. You can compare that to the DNA and RNA of the control flies that were not experimentally evolved for longevity. And you can see many big differences across different tissues related to heart function, related to immune function, related to nervous system function, right? And so we did something similar with that data. We designed some supplements, some novel combinations of Chinese herbs we found when you fed them to a middle-aged normal fly, it would double its lifespan. And then we did trials showing that in people, it improved biomarkers of aging, and in some cases could help a lot, in particular with neurodegenerative disease, that can take mild or moderate Alzheimer's and roll it back. So again, it was quite interesting. But again, we were playing with supplements because it was an easy and cheap thing to do. I have no doubt that by taking a gene therapy or a small molecule approach, you could probably get something more effective, hitting the same target combinations that the AI had identified, right? And so now we've been looking at more depth. I did some work with Ganesh like 10 years ago. In the last year, I've been looking again at Methuselah fly data. So the Methuselah flies now live 5 to 8 times as long as control flies. It was only like 2 or 3 times as long 10 years ago. And it's amazing, like the current flies, which live 5x control, they're way more different than the flies from 10 years ago that live 2x control, as compared to the difference between the 2x and normal. Like the difference from normal to 2x was nothing compared to the difference between 2x and 5x, which is quite interesting. Like it seemed a bit like, if I want to overgeneralize a bit, to live twice as long as a control fly, you need to dodge various diseases. Whereas to live 5 times as long as a control fly, you need to dodge those diseases plus fix some more fundamental problems to do with aging, because the gene, there's large changes in a more focused set of biological networks in the current Methuselah flies that live 5x control. And we've done a network simulation model of transcription factor activity in the flies, and you find a few transcription factors that are variant in the long-lived flies, which seem to be causal for the transcription factor activity networks in the long-lived flies. So I'm not really the expert on the biology underlying this. So we're working with Axel Schumacher, who was the inventor of the epigenetic theory of aging some time ago, and then a few other folks with bioinformatics background who were digging into sort of the why of the biology results and how you would best design therapies based on it. Now, my own main contribution here, apart from sort of organizing the project to bring the data together with the AI and the researchers, has been to introduce some novel machine reasoning tools alongside the standard sort of machine learning pattern analysis tools. Because one of the characteristics of genomic data sets is they're big in some ways and small in others, and in a way that's bad for AI analytics. So, I mean, with the flies, we have like 15 cages of flies. Within each cage, there's a fair amount of genetic homogeneity. So you have basically 15 data vectors, but each one of these, it's like, hundreds of thousands of SNPs and 14,000 genes with different expression. So you have 14,000 dimensional vectors, right? I mean, if you know anything about statistics, it's very hard to tell what's going on comparing 14,000 dimensional vectors, right? Similarly, we work with Better Humans organization to study DNA from supercentenarians, but we had like 40 supercentenarians, but you've got like 600,000 SNPs for each guy, right? So you have like 600,000 dimensional bit vectors. I mean, this is bad. It's big in one dimension, very small in the other dimension. Standard statistical and machine learning tools throw up their hands in despair, right? What you need to do to make sense of cases like this is bring a lot of biological background knowledge to bear on the data analytics process. So what we do, we curate a large knowledge graph of biological information, and this is in a special knowledge graph format associated with our OpenCog sort of proto-AGI project. We curate a large knowledge graph of data relevant to genomics and biology in general and longevity in particular. Then we have a way of using the knowledge in this knowledge graph to condition and guide the analysis of the genomics data, and bringing that background knowledge to bear partially compensates for the small number of samples that you have relative to the dimensionality of the data regarding each sample. So when I keep saying machine learning and machine reasoning, machine learning sort of looks for patterns distinguishing case versus control, like long-lived fly versus short-lived fly, inflamed tissue versus non-inflamed tissue, supercentenarian versus person who dies young, right?
Mm-hmm.
Machine learning finds patterns distinguishing one population from another. What we're using machine reasoning for is to sort of logically understand the implications of the background knowledge for the data set at hand, which then guides the machine learning algorithm. And so that's sort of a long story, and it may be a bit too in depth. But anyway, that's and another aspect which is important is what's called transfer learning. So transfer learning in AI is the ability to take something learned about one case and have it help you figure out something about another case, right? Mm-hmm. So like if you don't have many examples of a certain language like Mongolian, maybe you trained your language translation algorithm on 50 other languages. It learns something about language in general, and that lets it deal with Mongolian translation with a smaller sample size than it would need without transferring from that background knowledge. So what we're doing here is we're trying to transfer knowledge from the fly to the human, right? So we only have data on a few long-lived fly populations, but there's a lot of data about fly genomics. There's a lot of general data about human genomics. And we're trying to use all that to do transfer learning to figure out like which of the patterns regarding what makes a fly live a long time will transfer to make a human live a long time. So like cancer is a major problem here because flies almost never die of cancer. And a significant bunch of the things that you could do to make a fly live a long time will kill someone by giving them cancer, right? So that's an example of the kind of thing a transfer learning algorithm has to figure out and work around in transferring potential aging interventions from flies to humans.
Yeah, I think it's a good way to frame the problem and understand the difference between machine learning and machine reasoning. And also you mentioned a little bit about OpenCog, and I was wondering if you could explain briefly your idea about decentralized AI and Singularity Net, which is a project you've been working on for a long time.
Absolutely, yeah. So I'm involved with a bunch of different AI-related software projects, which sort of address different layers of the tech stack. You could say the application to longevity biology, that's a particular sort of vertical area application, which you could say lives at the top of the AI tech stack. Then I have an AI framework called OpenCog and a new version of that, which is called OpenCog Hyperon. And it's both an attempt to build a real thinking machine that can think like people and ultimately better, and it's a practical toolkit for building AI applications now. Like we used it behind Sophia and some of the other Hanson robots. We use it for genomic data analytics. And OpenCog is different than the deep neural nets and large language models that are currently so fashionable in the AI field. It can be used together with them and hybridized and connected with them. But rather than a sort of hierarchy of simulated neurons, the key data structure of OpenCog is a sort of knowledge graph. I mean, it's a weighted labeled metagraph, like a graph of nodes and links pointing to each other, where you have some fancy things like links spanning multiple nodes, not just two, or links pointing to whole links or subgraphs or something. So we have this big graph with weighted labeled hyperlinks in it, and we have various ways of encoding knowledge in this graph. Parts of the knowledge graph can act sort of like a neural net. Parts are more like a logic system. Parts can embed executable programs that do things with the program code is represented in graph format. So we have this big knowledge graph. Then we have various AI algorithms act together on this knowledge graph in a concerted and synergetic way, like logical reasoning algorithm, an evolutionary algorithm that tries to evolve programs doing certain things, a hierarchical pattern recognition algorithm. All these things can be encoded as programs represented within the graph. And these are programs that act on the knowledge graph to modify the knowledge graph and put new knowledge in there, right? So this way of trying to build an AI system as a reflective, self-modifying, dynamic knowledge graph is a little different than the deep neural net approach, although there's certainly some similarities. They're both networks of small processing units connected to each other and influencing each other. But I think that the open knowledge graph centric approach is better at capturing abstractions of data and experience, which I think is important for creative leaps of generalization. If you look at what large language models and convolutional networks and the other currently fashionable deep neural nets are doing, these are mostly storing all the data they've seen in a fairly direct way, and then sort of weighting this data and averaging it together and so forth. They're not trying to form an abstracted version of the data, which I think is something that they're missing and that OpenCog has. But then there's a whole story behind OpenCog of how we try to, in this knowledge graph, deal with the different kinds of memory and the different kinds of pattern recognition and learning and reasoning that the human mind does. Now, you mentioned SingularityNet. That lives on a one level down of the tech stack from the OpenCog system. SingularityNet platform, which I've been working on for the last 7 years or so. SingularityNet platform is simply a way of taking a number of different AI software agents living on different machines and let them coordinate together to solve problems and do things without any central owner or controller. So just like Bitcoin is a digital money where there's no central mint, there's no central owner or controller, the minting and the money management are taken care of in a decentralized network. In a similar way, SingularityNet, it's a decentralized network of computers doing AI processing without any one controller managing it all. And this has various advantages to it. I mean, it allows you to create a network that's very robust and that no one can easily take over or control. It also lends itself to sort of a wide variety of economic incentive mechanisms, right? Because a network isn't owned just by one company. Different parts of it can be owned by different people who then have an incentive to both make money on their own or achieve their other goals on their own, and to make the network as robust as possible so the network itself can support their own machines. They're part of the network as well as possible. So that's the SingularityNet layer, basically. And there's a lot to be done to make an AGI work. In some ways, it makes it harder to build it on a decentralized infrastructure than just doing it on the centralized server farm. On the other hand, in some ways, it can even make it easier because it pushes you toward more of a sort of biological-ish mode of doing things. Like, I mean, the brain has no central controller either, right? I mean, in some ways it does. There's the autonomic nervous system, but the autonomic nervous system is not telling the parts of the cortex what to think about, right? I mean, the brain is quite heterogeneous and decentralized in its operation also. So I think that while there's some software hassle in building a decentralized underlayer, I think that also lends itself to the sort of open-ended self-organization that one wants in a human-like intelligence.
So in a way, you have a kind of network of computers working together.
We do have that. Yeah.
I had a kind of a more, let's say, concrete question. So you've been long working in China. Are you still involved there? And do you think that China at the moment is a better place than the US or than Europe to develop AI?
Well,
Or there's more
I lived in
reasons?
Hong Kong. I lived in Hong Kong for 10 years. In early 2020, I relocated back to the US, and I'm now living on a small island off the coast of Seattle. I mean, I moved back most proximally because Hong Kong's COVID policies were really annoying.
Yeah.
The political shifts in Hong Kong also were not maximally amenable to me, although they didn't really change everyday life in Hong Kong in any way. They changed the vibe of the place a bit. But my wife is from mainland China. She's also an AI PhD, so I mean I've got family connection there, and I am in close touch with a bunch of folks from the Beijing AGI R&D world, which is quite active. But I'd say for the last few years, my work has been not so tied to what's going on in China, partly because SingularityNet is based on a cryptocurrency, a utility token, and utility tokens are not legal in mainland China. So, I mean, the core business model by which I've been driving forward my AI work is not legal in that country since October 2017 or something. I mean, it used to be. I think that in a more general sense, I mean, China is full on for AGI now, like the US is, and like parts of Europe increasingly are, right? Everyone, I think, now can recognize that building general intelligence is a practical thing to at least work toward in the near term, rather than just a science fictional pipe dream, as many people thought a few decades ago. So China is full on for AGI. They've got key labs for AGI and AGI conferences all over the place. Nevertheless, I would say the nexus of applied AI and AGI innovation is very much USA. I mean, US invented AI in the 1950s and has by far had a leadership position through the whole history of the field. I mean, if you look at who's been doing AI since the 60s, let's say it's US, Canada, UK, France, Germany, Russia, Japan, right? I mean, so there's been a longstanding AI field in various places. China's AI community is quite new by comparison. And I'd say most of the older generation of Chinese AI researchers are not so sophisticated. The younger generation were mostly trained overseas and came back to China and have, world-class international perspective. But on the whole, it seems China has excelled at taking AI algorithms and scaling them up, running them on huge amounts of data and compute and deploying them. But China has not excelled in developing, weird new approaches to solving AI problems. I mean, it's been pretty much US, a little bit of UK, but say DeepMind was a UK company funded by US venture capitalists predominantly, right? So it still had a big US hand in there. I mean, that was Peter Thiel and so forth. So feels like US still has by far the best environment for both fostering wild new AI ideas and doing the initial tech transfer of AI ideas from research into initial commercial deployment. But then once you have the initial commercial deployment, who can scale it up, to massive scale fastest? China is very, very fast at doing that, right? And they have some data advantages because the government can just take everyone's data and do whatever they want with it.
Yeah, I was going to say, for example, for longevity, they should be normally in advance because they have more than 1 billion, 1.5 billion people, and they don't have as many restrictions concerning health data and so on that we have in our countries. So what do you think should be great to have more sharing of AI and sharing of health data?
About data, I would say the further you move toward general intelligence, the less data you need, right? Like ChatGPT has read a lot more than you or me, but it's still a lot stupider than you or me, right? So I mean, so once you can abstract beyond the knowledge you've consumed, you don't need as much knowledge. And the reason LL needs so much data is because they're not abstracting; they're just spitting back context appropriate averages of specific data items that they've seen, right? So I mean, China has an advantage of having a huge amount of data, but as we move toward AGI, that advantage becomes less and less meaningful because an AGI doesn't need to see that many variations of almost the same thing. I mean, China's graduating more AI PhDs than anyone else, which is a big advantage. But I think the culture and the way the institutions there work is not that conducive to sort of freewheeling experimentation. Like what I saw there is the grad students have a lot of wild, crazy ideas, but when they get a job, they just got to do what their boss tells them. Like they don't have as much freedom to experiment with crazy new approaches, and that's a culture issue, and it's an institutional organization issue. It's not that easily solved just by having money, data, and will. Actually, that sort of problem can sort of need generations to get old and retire to be solved. So I think innovation will continue to be driven in the US in as much as it's driven anywhere. But I mean, one thing I'm working toward with SingularityNet and OpenCog is to make it as international and broad-based as possible, right? Like so SingularityNet, we have major AI labs in USA, in Russia, in Brazil, in Ethiopia, in Hong Kong, and then smaller teams in different places. And I think AI and AGI should be developed cooperatively by people everywhere on the planet. I would say, while China has some restrictions, like cryptocurrency is illegal, and they have the great firewall that blocks some messaging and some Western AI services. I mean, on the other hand, the international nature of the AI research endeavor is heartening and impressive, right? Like Chinese researchers are posting papers on archive.org and they're pushing code into GitHub repositories. So sort of an open scientific pursuit of early stage ideas seems to be going on globally in a quite robust way. But then when you take an idea and scale it up for commercial deployment, then typically it becomes proprietary and specific to one country or one company. And that's, I mean, if we succeed with what we're doing in decentralization with SingularityNet, then that stage of practical deployment will also become open and decentralized, more like the research stages now.
So on the road to transhumanist utopia, there might be some risk along the way that we could encounter. Some people call that existential risk or global catastrophic risk. So do you share the same worries as people like Nick Bostrom, Eliezer Yudkowsky, or Max Tegmark? And if not, why? Why do you think they're not, they're wrong?
Yeah, so I know all those guys quite well. And I mean, there are many different shades of attitude among those three individuals you mentioned, of course, but I think that in creating human level or superhuman AGI, we are in a way leaping into the great unknown, and anything is possible, right? I mean, we can't rule out for sure that AI may annihilate everyone. We can't rule out for sure the AI might, as soon as it gets to an IQ of 307, see the aliens that are hiding in front of us in plain sight, able to see because we're too stupid. And I mean, it might realize that we're all living in a simulation world and hack out of the simulation into the meta simulation. I mean, most likely something much weirder than any of these things will be discovered, right? I mean, it's like if you're living on a little island and then you get some super being, it can build a boat to take you to another continent where there's untold wonders, but maybe it can also modify your body so you can live undersea or bring you out in space. I mean, who knows? So if you want to say we can't rule out the possibility of something really bad happening, I mean, rationally, yeah, we cannot rule it out, right? I mean, we're entering into an unknown era. Humanity has done it before. I mean, when we invented language, when we invented agriculture, when we had the Industrial Revolution, I mean, in all these cases, if you look at them in foresight rather than in hindsight, we were moving into some radical unknown with tremendous risks that were hard to even articulate, let alone quantify. On the other hand, if you want to claim that bad outcomes are likely, I don't think anyone has made a solid argument for that. And both Yudkowsky and Bostrom have tried to make that argument, and I think they have failed pretty badly, but have not admitted their failure, which is kind of annoying. I don't think Max Tegmark has argued that bad things are likely. He's been a bit more sort of open and balanced. I mean, the argument Yudkowsky has given why bad things are likely is like if you pick a random mind out of mind space, the odds that it likes people will be very low. But I mean, to me, that's like saying if I pick a random kid on the planet, the odds that they love me is low. Yeah, but my own kid loves me because I raised them, right? I mean, the AI that we're creating, we are raising that AI. It's not a random AI. It's an AI that we are engineering and teaching to help us, right? So, I mean, you have to argue, why would an AI that we had engineered and taught to help us and that seemed to be compassionate and nice to us, you have to argue why that AI would suddenly turn around and decide to murder us instead. And there's no particular reason I can see why it would, right? I mean, Bostrom's argument is what he calls like instrumental convergence. He's like, every system in the world to survive needs to maximize its energy resources and minimize the resources competitors get. And that's just evolution read in tooth and claw, right? But I mean, we already know this is a bullshit way to look at natural evolution. I mean, there is natural selection, but there's a lot of complex self-organization happening in the natural world as well. So I don't think that sort of nature read in tooth and claw approach even works for evolved systems, really, let alone for engineered systems that aren't necessarily fighting for survival. I mean, all the different AI systems on the planet can just network together and share mind stuff and cooperate. They don't need to be viewing themselves as separate entities that are fighting for energy against humans or against each other or something. I mean, seems like the arguments that a bad outcome is likely are very, very feeble and don't make much sense. The argument that a bad outcome is possible, well, yeah, it's possible. So then it sort of comes down to your philosophical stance. Some people will articulate what's been called precautionary principle, which is like, if there's a risk, don't do it, right? And some people will advocate, such as Max Moore, one of the primary authors of the philosophy of transhumanism, some people will advocate a proactionary principle, which is like, if there's something that has amazing benefits, then, look at the cost of doing it versus the cost of not doing it, give a rational cost-benefit analysis, proceed if the benefits seem to outweigh the costs, right? So I think those are two different stances, right? And if you take a fundamentally precautionary stance, you would not have invented language, you would not have invented agriculture, you would not have had the Industrial Revolution, and you would not create AGI. You wouldn't create a longevity pill either, because who knows how that might upset the balance of society. We can't prove it won't, right? If you take a proactionary stance, then I think on balance, there's a strong argument to create AGI because it can help us cure aging. It can help us run government better. It can help us make molecular assemblers that will 3D print us whenever we want. It will cure disease. There's so many amazing things it can do. Benefits are tremendous. And it seems sensible the risks can be kept under control. So to me, the biggest worry is our society is doing a stupid job of keeping nearer term risks under control. Like most AI on the planet is oriented toward what I can think of as selling, killing, spying, crooked gambling, or plagiarizing, right? I mean, we're not primarily developing AI to help with education, medical care, creative arts are down, but only in an exploitative way. We're not mostly creating AI to help people, actually. We're mostly creating AI to serve one company or one country at the expense of its competitors, right? And I think that gives a clear risk that we get what we're asking for, and we get AIs that only do good for its owners and not for others, right? So I think what we need to focus on is creating AGIs that are working for the benefit of humanity and its transhuman descendants, rather than working for the guys who own that AI. And that's, to some extent, I think the hand-wringing about existential risk is almost a disinformation campaign that distracts attention from the nearer term and more palpable risks of sort of powerful parties developing AI that serves them rather than the rest of us.
Yeah, that's strange because I heard this kind of ideas quite a lot, especially in, let's say, left-wing side of the political spectrum in Europe.
Yeah.
I must say I'm not convinced. Okay, discussing with the most intelligent, listening to and discussing like today with very well-informed and very competent people, I'm fascinated by the thing that they so much diverge about this question of existential risk. It is absolutely fascinating. But okay, one of the arguments is of the people who think that it's real risk is if we have a technological singularity, so if it changes brutally, let's say, we don't have the chance, we will not have a second chance to make a mistake because we will disappear in the process. What do you think about that? So maybe in three aspects of the question. The first one is, do you think that there will be a singularity or will be a slow process? The second point is, what do you say to people who say, let's be careful and wait, that we are sure that it's going to, or pretty sure that it's going to be a good singularity? And the third question is, do you think that an open way is better, open source way is better than a closed one to work on AGI? There also, I think you diverge. Nick Bostrom is more in favor of some kind of closed work to limit risk, and you are more in favor of an open work.
Yeah, so first of all, yes, I think this singularity is near, as Ray Kurzweil has said. I mean, there will be gradual development, but at some point we'll get an AI which is able to do computer science and electrical engineering and AI theory itself. And once you get to that point, I think you get singularity pretty soon. The AI will make a smarter AI, which will make a smarter AI, and so forth. I mean, what do I say to people who want to slow down is, I mean, it's not an option, so it's not that worth debating. I mean, you're not going to convince the Chinese government to slow down. You're not convincing Putin to slow down. There is no rational world government that's going to peaceably convince everyone to slow down on AI research. So it's kind of a moot point. I mean, you can slow down, you can choose not to do AI development, but others are going to. And if one country decides not to do it, the other countries will just speed up to gain more and more relative advantage. So it's a purely notional question. It's like asking, should we all roll back to the Stone Age because maybe living as Stone Age tribes people was a happier life? I mean, maybe it was, but it's like not in practice what we're going to do. So it's like purely a sort of fanciful speculation question. That we can guide development in certain ways, and this has to be done carefully, because if we do slow down development a lot in the US and China doesn't, then what's the consequence, right? I mean, on the other hand, all humans do have some common interest in promoting human welfare, right? So I mean, at some level, we should be able to make agreements that prevent us from having a malevolent sort of AI arms race. But I mean, international cooperation is not great. So about centralized versus decentralized, I mean, there are no guarantees. I look at the internet and the Linux operating system as two fairly nice examples of decentralized networks, which are working out pretty well for humanity. It's not that bad guys can't use them. I mean, bad guys are using the internet to organize terrorist activities. Probably Iran's missiles run on Linux, embedded Linux, and so do Israel's, right? I mean, so these are decentralized technologies owned by everyone and no one, and they're used by good and bad guys alike. But I think on the whole, they've both been for the benefit of human species. I mean, I know in the area of biotech, everyone's so worried, if we let people have broad knowledge of genetics, then terrorists will do something. So we need to keep it locked down. But, what was COVID caused by? 2 lockdown centralized government labs in US and China collaborating with each other, right? Like the big biological issue we had was caused exactly by crappy protocols among central labs in two countries collaborating quietly with each other, right? So I mean, I don't think there's evidence to support the idea that keeping these things locked down and under the control of a small number of elites will make it safer. And I mean, you could argue this in any number of ways. Like open source code is widely used tends to have fewer bugs than proprietary code because there's more people looking at it to remove bugs, right? So there's certainly no guarantees either way, but I feel that open networks on the whole are more robust. And I also don't think locking things down fully is even a meaningful option. Like unless the AGI was really developed just by Eliezer Yudkowsky locked in his basement for 10 years coding. I mean, if you have a team of people working on something, one of them will quit and take it to a competitor. One of them will sell it to an enemy government for $10 million. I mean, these sorts of things always happen. Like in real life, you're not keeping something super locked down very long if it's really important and lucrative, whether you're explicitly decentralizing it or not.
Okay. Yeah, that's a good clarification. So we're reaching maybe the end of the conversation. We had a few more questions. Maybe we could do like a quick lightning rounds where you answer in...
Sure thing. True or false question.
Yeah, 2 or 3 sentences. So what is your view on artificial consciousness?
I am a panpsychist. I think everything in the universe has its own flavor of consciousness. And if you make an artificial system that has similar structural and dynamical patterns to a human mind, then it will probably have flavor of consciousness similar to that of a human being.
Okay.
Yeah, that was my next question about, if I remember correctly, in your book, Cosmos Manifesto, you had this idea of a global consciousness. But what I never understood when I read the book, it was you were saying, if I remember correctly, you were writing that you can prove this, let's say. And can you explain again what you prove in 1 or 2? Maybe it's difficult, 2 or 3 sentences, but still, if I understand correctly. Yeah?
I don't know that we can prove there's a global consciousness to everybody's satisfaction. It's obviously a vexed question among professional philosophers, and there's no agreed philosophy of consciousness, right? I mean, I think once we have more advanced technologies, we'll be able to explore this in interesting ways. Like, what if I wire my head into your head? Can I feel your consciousness as if we're like Siamese twins? What if I wire my head into my phone? Can I feel the dynamics happening in the phone, or wire my brain into Sophia's brain? So through brain-computer interfacing and brain-brain interfacing, we may move on to different ways of assessing the consciousness of different systems. And so then it'll be less of a sort of voodoo topic. Right?
Sorry, maybe my question was, or maybe it's another question, but just, do you think that the universe was already conscious before human came?
I do think so. Yeah.
So yes, you're one of the father of Sophia, one of the most advanced robot created, and I think I can see maybe the picture behind you of Sophia, if I'm not mistaken.
That's Desdemona, who is Sophia's little sister. And on the topic of consciousness, by the way, I just got the first copy of my new book, The Consciousness Explosion. So you can look at theconsciousnessexplosion.ai. You can find a free PDF of it, and very soon there'll be places to buy hardcover, Kindle, paperback, and so forth.
Great.
And that you can find all you want to know about my thinking on consciousness and the singularity and more.
We will put this link in the description. Yeah, how do you see the future of robots briefly? Because you mentioned we didn't make a lot of progress in the last 20 years.
I think that right now getting intelligent human-like robots is mostly a software problem. We just need smarter software. The robot bodies are already good enough. I mean, there's a problem of scaling up manufacture to bring the cost of the robot bodies down, right? But other than that, it's a software problem. So I think if we get a singularity by 2029, within a year or two after that, we're going to have extremely capable robots rambling around everywhere. And I mean, robots also can play a role in getting us to the singularity, because AIs that are rolled out in robots can learn about the physical world and the human world in a way that helps upgrade the AI's mind as well. But I think AI software is the main driver of growth toward the singularity. It's not robotics or biology or anything else. It's AI cognition.
Okay, next short question. Do you think we live in a simulation?
I have no idea. I suspect the true nature of what we think of as reality is probably nothing like any of our current concepts of reality physics or simulation or whatever. It may look quite different in 10 years to us once we've upgraded our brains. I mean, much as, chimpanzees or primitive humans looking up at the sky had no idea what the Milky Way was, right? It was like, it turned out something totally different than any of the weird ideas that they imagined.
Yes, that makes sense. And two short question then. What is your view on the Fermi paradoxe?
Well, if we live in a simulation, then that's easy. The programmers were just lazy and didn't put any other intelligences in there, right? I mean, I like John Smart's idea, the transcension hypothesis. Like when a civilization gets smarter and smarter in pursuit of maximum intelligence, it packs its processors closer and closer together. But that means eventually it becomes so dense and massive, it's a black hole. So then all the super civilizations, as soon as they had a singularity, they turned into black holes. And maybe they're communicating on the black hole, white hole Wi-Fi network or something. And only those of us who are still pre-singularity are out here outside all the network of black holes. But I mean, who knows? That's sort of a way of saying, like, we don't understand the universe terribly well, right? Like the post-singularity civilizations might have downsized themselves to become intraparticulate intelligences, and what we think are random quantum fluctuations are actually the humanly incomprehensible thought patterns of the downscaled super AI from another civilization, right? Like, I mean, our job now is to multiply our intelligence by a factor of 2 or 3, then let the smarter versions of ourselves, or the smarter AI mind children we've created, figure out the next step, I suppose.
Yeah, it's always tricky to answer those questions. And finally, what does utopia look like for you?
Oh, I don't need to figure that out right now. I mean, I think I would like to upload my mind into some radically transhuman form and try to merge with a superhuman God mind in some direct way. I would also like to leave a version of myself in, let's say, a 25-year-old style version of my body. I'm 57 now. I'm starting to degenerate already. Not too fast, but and get rid of headaches and upset stomachs and the common cold, and just like live my best human life for a few thousand years and see how it goes. But I mean, whether any of these things is a true utopia, I mean, who knows? But I'm interested in exploring a variety of different horizons, to be sure. So, but before we let each other go, I want to also highlight the Rejuve.bio project, Rejuve Biotech, which is doing the long-lived fly research that I mentioned. If you look at their website, they're doing an equity crowdfund now. So if you're the investing type, you can actually buy shares in Rejuve Biotech by a service called Net Capital. And then there's another part of Rejuve called Rejuve.ai, which is a utility token, sort of cryptocurrency-based project. They're offering an app soon that you can download. It's in beta now. You can download the app and upload information about yourself and your body, and it will use AI to give you some information on your health and longevity. So Rejuve.bio or Rejuve.ai are interested to look at for some longevity research and technology development in my general orbit. Then SingularityNet.io will lead to a bunch of information on SingularityNet platform and OpenCog and so forth.
That is already a part of what was my last question. It was for the people listening to you, what and who are, let's say, globally agree with you. What should they do, you think? In what should they invest concerning money? You said it already a bit, but concerning their time and their energy.
Yeah, this is a question I'm asked a lot, and I'm trying to come up with better answers. But what I could say for now is, if you go to SingularityNet.io and give your email address, get on our mailing list, and then as we develop new ideas and organizations, you'll get an email explaining what it is. I mean, if you're a software developer or a researcher in relevant fields, SingularityNet has what's called deep funding, which is a grants program for work on AI and singularity related projects, which may be of interest. But we're aiming to put together an organization of people interested in creating beneficial general intelligence, and we're looking at how to provide ways for people to help out more so than exists now. I mean, so one thing that we will roll out is a way for people to interact with early stage AGI systems and just teach them by talking to them and explaining to them what human life is all about. And I think there will be a need for that, for people to pitch in and teach human ethics, values, and culture to the AI. So if you go on SingularityNet mailing list, we can at least notify you when that sort of human teach the AI interface is ready.
All right. Well, we will make sure to put every links in the description and to point to your Singularity.net and thank you again, Ben, for this conversation. It was fascinating. We covered a lot of ground, and it's always great to talk about these topics. And I hope we will meet after the Singularity, maybe in the
hopefully we can meet even before the Singularity. All right, bye-bye. Thanks, everyone.